Hey everybody, Kit Merker here from Noble 9, and I'm with Layla Sells, who's an engineering manager at Google. Welcome, Layla.
Thank you, Kit. It's great to be here.
Nice to see you. So we were talking a little bit beforehand, and I know you've had kind of an interesting career path. And I know you're working at Google now, engineering manager. Maybe you could just share some of the crazy jobs you had along the way and how you ended up in this position.
Yeah, it was definitely a meandering path. I did not really set out to be here. So I did not start out on a path to tech at all. I was a high school dropout. I had some really rough teen years. And my first college class was really not sort of for anything other than it was part of a court mandated path to getting emancipated. And so I ended up doing that and got very lucky that I accidentally took a computer science class. I was so computer literate, I ended up taking Intro to Computer Science, or computer programming, I think was the title of it. And I assumed that that's where I would learn how to, use email and write a document. And instead I learned C++ and loved it. And so anyways, I ended up getting my computer science degree. On the way, I worked in sales. I had my actual paper company time. And I also worked on a proton accelerator, doing electrical work and sort of building flight path and mechanical engineering, a little bit of all those things. And then ended up going to Microsoft, where Kit, you and I worked together for a bit. And I started sort of close to the hardware world that I had been in before, in the early sort of tablet and mobile space. And then ended up sort of making a few changes. I switched to PM at one point. I went to Office Live, which was in an early sort of startup-y services world. At the time, it was literally 4 boxes under someone's desk. So things have changed slightly when we talk about a service being run. And then from there, I got my MBA thinking I was going to go more down the business route. And really figuring out, I had always been pulled between sort of this love of computer science and then solving the larger business piece. After getting my MBA, I was like, I missed the code. And I went and joined the .NET CLR team, worked on sort of the guts of that for a while, and then had my first manager role leading the compiler teams. So C#, Visual Basic, and F#. And really loved the space. And for reasons that had nothing to do with the work or my actual team, I ended up moving to Office and working on graphics, which was a bit of a different thing as well. And then from there led a developer experience team where we had PMs, engineers, and writers. And then my last role at Microsoft, I ended up doing a rotational program in the office of the CTO, doing some technical advisory work, looking at intelligent edge and cloud and developer strategy and all of that. And I was always sort of still pulled in sort of what I loved about my job and what I felt I was supposed to be doing in my job. And in that, I ended up finding out more about Google's philosophy of managers, and it really resonated. One of the other side things I did sort of on the path is I'm a certified career coach. And I love that Google sort of cares about that side of it. And so I made the decision to switch to Google. And that's where I am now. And I'm leading a team that focuses on building out the client libraries, connectors, and samples for our storage and database products on GCP, which is super fun. The team works across 7 different languages. There's just really close to the guts. And then I also get to do all of the people side and coaching and manager piece of it that I love. So I've sort of landed where I get all of the best parts that I enjoy after a bit of a meandering journey.
Would you say that you kind of wasted time doing all that different stuff, or would you say that like it accrued in somewhere you picked up things along the way that you're still using, or is that kind of like throwaway? How would you look at that?
Definitely not throwaway. There are times where I've stopped and really reflected in the gosh, if I had just come to Google originally as an engineer, sometimes I think maybe I would have been more successful. I feel like I culturally align more naturally. And then at the same time, I can't look back and pick anything I would give up. Not only did I learn really important lessons that I apply every day in each role, but I also got a lot of value out of it. For me, part of my, I think, strengths is being able to bring together so many different perspectives and places to look at what we're building. And I don't think I could have done that without so many different sort of areas that I looked at and went through. So I certainly wouldn't trade them. And I can look at every single role that I've been in and see where I apply things that I learned in that role today in my current role.
Do you think, a lot of people seem to want specialization, you know what I mean? Like they want specialists who are really deep on a lot of topics. And obviously you work on a lot of deeply technical areas. Do you think that there's an overemphasis on specialization in sort of tech, or do you think it's right for some people? How do you think about specialization?
So I think it depends a little bit on the person. We do need some specialists, but we also can't have all of them. Two teams that I've worked closely with, actually one team that I'll just speak to that had people that were true specialists on the compiler team. You don't get a lot of people who are like, sure, I'll take a role like working on compilers. That sounds fun. And most of the people in that space had, masters in or PhDs in compiler optimization. They had spent time doing this, like this was their life's work. And not having some people with the deep understanding and where did all of that come from. Same was true on sort of .NET and the garbage collector and all of these places where you really don't start having high levels of impact before you understand a system so deeply. Same's true with things like kernel teams and areas like that, where you really need the specialization. The problem is that if you only have folks who are complete specialists, they miss out on how real people will use it. And when you end up with people who is like total experts, then it's like, oh, well, they'll figure it out. They'll get it. Oh, they don't need to know this piece of it. And that's never true. And so every team, even for the teams that really do require specialists, I think you need a mix. And then the other piece is, I think it takes sort of a desire. Like, do you want to be messing with the same area for a very long time? Do you feel good about yourself by knowing the entire code base, where everything is, and being able to go in and address like really gnarly, deep problems that you couldn't do unless you understood the entire legacy of the code base and how it got there? Or do you like new things? I've worked on a different type of technology every time I've made a change. Some people say only change one thing at a time. And I think that often leads to specialists because they're scared that it's like, oh, I can't change too many things. When the reality is like, if you truly learn how to be a specialist in an area, becoming a specialist in a second area isn't that hard. And so more of it. So you can sort of pick up these different specialties one at a time. It's hard to like maintain the deep expertise in all of them at the same time, but you certainly can. I sort of think I have some specialties in sort of the breadth side of it, which may be less common.
Well, I want to shift gears a little bit. It's a fascinating conversation. Maybe we'll come back to some of it, but a couple of things you said that I want to just tease a little bit. You said that one of the projects you worked on was 4 servers under the desk, and that service reliability has changed quite a bit. And I know, love to hear your thoughts on that, but even maybe a more particular piece of it, which is about user empathy when it comes to reliability. So not just sort of the architecture, but also the way that real people kind of use software and use tools, use infrastructure to solve problems. How do you sort of think about that problem? Maybe you can share kind of your thinking on it.
Absolutely. And that's part of the reason why I like being in a role where I'm close enough to how developers actually use what we're building. Because if you just build something, and it's great to like know that it's used a lot, but without really understanding, I like understanding that of how do we bring it forward. And there's all the talk about, which service has the most nines, and that matters. Like back in reliability does matter. If you don't get that, like you have bigger problems. But at the end of the day, like it's just not enough. Like nobody really cares about awesome. Your service is great. and then my actual solution is falling over, right? And so there's a critical part that I don't think is thought about often enough, is what does it take to make sure that what people are building on top of the platform is reliable? And so there's places where my team, since we build client libraries, that's a space where we think about like, what can we build in? Where can we do the ugly stuff that's hard to get right, retry, all of that in a way that developers don't have to think about it, at least most of the time, and allow them to sort of only do things if it's very specialized, but most of the time make it easy. And then the other thing is how samples are written end up being the design pattern of how you should build on top of it. And there's all these places where when people are building the system, it's like, oh, of course, people are going to use it this way. And this is how we've tested it. And it's great. Everything's awesome. And the reality is that people don't ever build things the way that you expect. Like some large cohort will, but the vast majority have interesting approaches. They don't have the luxury of just sitting around all day learning your system. They're trying to build their thing. And so the more that we can do sort of bridging the gap of making it easy to have the actual end experience really reliable is the thing that we have to focus on. And coming back to the piece that you brought up, the 4 servers under a desk, I think that's part of where that was the team where I learned a lot of this, in that I was tier 3 support. We were a small enough team that even at a large company, support calls came to us. And so I think I might have been the only PM, I was a PM at that time, who had admin rights. So I actually would log in sometimes to those 4 servers and I knew which room they were in, which was probably not a great thing. But we were able to just sort of go in and like fix things and address it. And I ended up on the phone with people all the time dealing with, what is this issue? Oh, great. And we had all these tools and it's like, oh, they did this. And it's like, oh, that's not how they're supposed to. It's like, well, it doesn't matter. They can. Right. And so I think the more you have that experience, you realize that anywhere where you go, those things are always true. It doesn't matter whether it's a service or a compiler or an operating system, people are going to use it in unique ways just because they're going to approach it from what they see, not the initial intent of how you designed the thing.
Layla, have you heard this law, Hiram's law? It's with a sufficient number of users of an API, it does not matter what you promise in the contract, all observable behaviors of your system will be depended on by somebody. What do you think of that?
I think that is the most true law I've heard in a very long time. If it is out there, it will get depended on.
So, so bringing this back to the client, I want to drill in, maybe daring to go a little bit technical here. Can you tell me more about the retry and why retry is hard? I mean, are you talking about exponential back off? I mean, what is it about the retry that's difficult? Tell me about that.
So I think, and there's a larger categorization of this, but I think for the average developer who is trying to learn an entire platform and just use it and figure out great, I'm making this call, I'm sending something, I'm getting something back, excellent, it all works. And things like the need for a retry, you find in production. Often it's not that you're going to find it when testing. These are transient issues. Often you find them under load. And yeah, that's one way. But it means that the person who actually built the system or someone understands that it's there, is watching for it. If you don't find it if you're not looking for it, you can end up finding these issues in really bad situations at peak load time. Who knows what's going on? And then you have to figure out what's happening. And then how do you reproduce it? You have to figure out how to contact. Is there a problem? What's going on? Ultimately, you realize that, oh, there's some error that happens sometimes. And then you have to find where is that? And you have to figure out, oh, do I retry? How often do I retry? Are you going to end up being retry so often or for too long, and then the backend system kicks you out? And
or my favorite, extended timeout.
Yeah, all of these things where it's then you end up with things taking too long and hanging and not going back. And so these are just challenging issues of working in an environment where everything is, internet dependent. and you have all globally doing these things, all of this that's largely not built into systems unless they're very sophisticated. And even then, there's a high burden on it. And so wherever we can find places to just make some of those things easy and abstract them away. And then at the end of the day, some of them for really complex systems who have very particular expectations, they may want to do things themselves, but they'll still want some guidance.
It's kind of like guardrails that you put in place so that the default is sort of like reliable by default in a way, is what you're kind of getting at.
Yeah. And this may not be an analogy that holds up, but I use it a lot just because I worked on the garbage collector for a while. And so that's a place where, usually it just happens for you. You don't want people messing around and calling GC collect. Like, that's a bad idea. Most people should not. And then if you're a financial institution with large scale failover systems that you can decide that you're going to take an entire set of machines offline and run a collection and stop everything on that machine so that you know that you're not going to hit an out of memory exception because you run with large objects, you should absolutely call GC collect and create a whole complex system around that. And so that's where I think over time, we will get more and more of these abstraction layers of sort of reliable by default or sort of smart defaults in place. And then how do we look for more of these sort of sophisticated, specialized uses? And how do you give any guidance for that?
What do you think about perfect software? Is it possible?
I don't know. You could probably look at something and be like, that is a perfect hello world for this language. But once you get more complex, you end up with trade-offs at any point. And so if you have very clear, here are the principles by which I'm going to judge its perfection, maybe, but I think it's really pedantic. I don't know. I can't.
Yeah, that's pretty good. I guess I'm kind of curious to hear more about, I don't know if you have any war stories of like a bad outage, because it's like my favorite stories are like those. I know you can't share if they're, confidential or whatever, but any, I know something came to mind for you, like any bad outage that you can tell us a war story about?
No, the like worst things that I had to deal with that I can actually talk about because they're so long ago, they weren't really reliability issues, but they were issues in thinking through the larger system at play. And I think reliability is just one set of that. And so part of the thing that I like is there's sort of the like core engineering that people get really excited about, like, oh, we build features and we ship them. Awesome. And then there's all these different areas around really the fundamentals, right? Like, or at least that's, Microsoft often called them fundamentals, but like performance, reliability, all of these different layers of it, I think matter.
Security and scalability, maintainability, et cetera, right? All the abilities.
All of the abilities that our software needs that sometimes gets forgotten, and it's really hard to fix after the fact. I don't know if you remember the Vista timeframe when we were on tablet and laptop teams, which is funny that like back then laptop was not part of Windows, says a lot. But at that point, I was sort of running the like dog food program because I was like, this is really obnoxious and hard to install. And there's all these weird things. And when you're working on like alpha level software, especially when it's at scale and when it's the operating system that you're trying to use to do your job, to build the thing, there's a bunch of issues. And the like install process was one of the things that was sort of pushed to later. And the marketing team needed to have it on their machines to sell. And no one had realized that it's like, oh, you sort of have to be an engineer at this point in the cycle to get it right. And so a couple weeks before before the big marketing conference, they were like, we need every person in marketing and sales to have Vista on their machine. And so they came to me and asked me to like write up some like guidance to help them. And it was like, this is not going to work. And so long story short, I ended up having to fly to Florida, have a booth at a conference, and I took every laptop away from the field, and we manually installed Vista on all of their machines and like manually backed up all their data. And all of this stuff that like should never have had to happen, but it hadn't been thought through of the whole system of like, how do we actually run this business? What are the other pieces of the software around it? And that ended up being super fun and like, yay, everything worked. But like, it was a very early learning of how many places beyond the initial design matters to the end result.
It's interesting, the idea of like how you deliver the software actually matters, right? The installer versus, SaaS, et cetera. And you did talk about these sort of the basics, or some people call them the non-functional requirements. And as a former product manager, right, one thing that I've considered is that now the service of how you deliver, a service, whether that's an API or a website or whatever, the characteristics of that service actually matter to customers. They're actually part of the product now, right? The idea that you have privacy and security and reliability, those are actually product considerations now, right? Where in the past they weren't necessarily, they were thought of as like engineering issues. How do you see that evolving? And is that entered into conversations you have with your product managers as you're sort of figuring out the business of delivering software?
I actually think that it's very common when I'm thinking of like engineers thinking about like, oh, what do they want to work on? That's a super common challenge that I run into where people are like, and this is part of like just getting advice from people that like, sure, they have one opinion. And so it's like, oh, I need to be shipping features, right? That's the thing that gets valued. And I think it is important when you're pretty junior that you learn how to ship a feature. You should learn how to build it. You should learn how to do all of those pieces. And then as people advance in their careers, I think they end up working more on these areas. And there's this point, often I see it sort of in the shift into a senior role, where at first they're sort of like, oh, what is all this stuff? And like, oh, is this maintenance work? Is this overhead? What does this mean? And so I realize that this is just something I naturally do all the time with people either on my team or coming to my team or going through this, is just reminding them about sort of what do customers actually care about? And that like, this is the middle piece and this is one part of it, and think about all these things. And also talking about the complexity of them, right? I think we get confused around what parts are sort of fun or interesting or worth doing. And so at least for me, like part of the reason I'm in a computer science space is I like solving the complex problems and then delivering something simple and elegant. And I think it takes people a while to realize that solving like performance problems and all of these that seem very complex, and it's like, oh, but there's no new feature at the end of the day. How do I know? Like all I've done is something is, like milliseconds faster. And I think the piece that helps people understand it is taking it to the next level of like, well, but what impact is that? Like, what does that mean to somebody? And like, what does it mean globally? What if you end up having that you're actually serving across the world and you already have a 250 millisecond latency built in, and then you have this piece on top of it? And how do these things add up? And like, where is there really, sometimes it's a very clear financial dollar around some of these things if it's delaying the larger system and if they're paying by different rates, especially now. And so I would expect that as sort of the shift further into the cloud space, cloud and mobile are both places where performance ends up mattering a lot in ways where, and it's not just speed, right? Like thinking about, so I work in a data heavy area, right? We do storage and databases. And so sometimes there's things of like, can we help someone know that this call just brings back the metadata instead of all of the data? So they don't actually have to be dealing with, ingress and all of that when they don't have to, if they're just trying to check some dates. And so there's other places where not only is that faster because you're not downloading a bunch of data, but it also affects the financial bottom line for customers. And so the more that people understand like why something matters, I think it helps them really understand these different capabilities beyond sort of like, yeah, features are cool. And some people, they're just always going to be more excited about the like 0 to nothing instead of taking something that's there and and making it really great. And it might just be different mindsets.
Very, I love your answer. I want to double click again on sort of the client, because I think there's this really interesting part of this, which is your client and API designed for the correct usage and thinking and taking into account the context, right? Like the idea that, you know what, we can make this faster, cheaper, safer for them if we make it obvious that there's two ways to make the call. There's a way that's the cheap and easy way if you don't need it, and there's this other way. And understanding and giving them sort of the ability to differentiate and have the intent by default, I think is a really interesting part of the design process. This is sort of maybe a key part of what you're really bringing into the client libraries, right?
Yeah, and I'd say, we're still early. I, joined this team a year and a half ago, and there's a lot of, in part, I was actually given two teams to bring together, and we've sort of established from zero to something, and a lot of sort of evolving what we're doing. And I think we're starting to get into this space of really looking at where is additional value in the library, right? Because I think there's always sort of this understanding that like, great, like people don't want to just hit a flat API. They want to be able to work in the language that they're working in, and they want higher level abstractions, and they want it to be idiomatic and work with their tooling and integrate into what they're already doing. And so that's been the sort of obvious value. And I think that like, I've sort of gotten my team to a place where they really understand that it's like, yeah, that's step one. And then like the next piece is like, where do we just make a bunch of other things easier? And where do we optimize and build more and more layers of just value as we realize what people are doing? And then the other thing that I think is super, and I mentioned this before, that's so overlooked, in that before, there's sort of the like how you document, and that's just an important thing, and people need to learn and understand, but really realizing that those things fit together and become the design pattern. And that's where I think we have more opportunity to sort of create some different layers of like, hey, if this is what you're trying to do. And the reality is that the large cloud companies, most of the systems, like the scale is big. And so when a small company and, it's like, oh, I have 100 customers, and they're like, I care about scale. You may not care about scale in the same way that other customers do. And so building in more places where people can understand all the different vectors of how they choose what's right for what they're building, I think is an important thing. And sort of people are starting to learn more and more of the things that they care about. And I think as that balloons, we will start building more and more into the platform and the APIs themselves to abstract it away again. And so you see this a lot.
Sorry, I was gonna. So there's an interesting point here too. At some point, you might have too much reliability. You might design for scale you don't need. I mean, we were talking before about people who aren't paying enough attention to this, but there's also the alternative, which is you could throw a huge amount of money and effort and time kind of over designing a system, building sort of gold-plated infrastructure, right, if you will, that is beyond your needs. Have you seen that happening? It's kind of what you're addressing with these APIs or the client libraries, right?
Yeah, and I think, gosh, you take them back to speaking about design patterns before. I feel like every student that's like gone through a CS program and their first thing that they build is like way overly design patterned. I definitely.
A factory for a pod, for a command pattern, whatever. Yeah.
Yes, I've definitely built some factories of one in my past time. There's a piece of like, can you get too secure, too reliable, too performant, all of those that I think for a large scale system that you expect every industry and everything to build on top of, not really. The place where you run into problems, I think, is where you overbuild for one of the vectors in a way that you compromise the others and you're not paying attention. And so that's the place where I think it's very easy to, focus on security and reliability, and then performance sucks. And then you go and fix performance, and so there's a little bit of whack-a-mole if you just get like super excited on like, this is the end all be all, this is the one we're going to address. And there's sort of this, like, if you take a step back, sometimes you need to over-index on it. Like, I feel like, gosh, it's now decades ago when like security was finally something that people were like, oh, we care. And that became a big thing, and threat modeling and everything sort of ballooned out of that. And there were security reviews, and it was the only thing that was sort of treated special. And sometimes you need that for each of the areas to get enough depth and expertise and focus and innovation in like, how do we really do these things? And so I think someone should, like, there should always be pockets of teams that really focus on how do you move the needle and solve some of these issues in different ways by really over-indexing on it. And then for the average solution being built, you have to be careful about the trade-offs, not just between them, but really like, are your customers going to notice? Is this the thing they care about? Are you even going to have customers by the time you get there if you take so long? And sort of, there's sort of this piece of like, if you take a step back and think about the reason why those pieces that we talked about, really that's about building trust. And so you have to look at like, what is the piece that is required to build trust with your customers? And that's the place that I would focus on, because you can only do so much on any of the things, and they're going to want the features and they're going to want all the pieces. And then at the end of the day, if reliability is the biggest thing for them because they can't have an outage, or security is the biggest thing, you have to understand like, where is the really important trust with your customers that you're not willing to break? And that's where you sort of start.
Well put, man. That's exactly right. Layla, thank you so much for taking the time. This was an amazing conversation. I really do appreciate it.
Likewise. Thank you so much, Kit. This has been really fun.
And everybody out there, this is Kit Merker from Noble 9 signing off.